Hello everybody. Today we are going to continue learning about binomial distribution, okay, and then we're going to look at various questions. So previously you learned about what is a binomial distribution, what is a binomial model. You also learned about the different characteristics of a binomial model, okay. Two of the very important ones are the fact that the outcome of every trial is always independent or must always be independent of the outcome of any other trials, okay. And also of course the fact that the probability of success, which is P, must always remain constant for every trial. And usually whenever the question asks for assumptions, whether one or two, okay, these are the two that we will always be talking about. Then you were also taught how to define a random variable, a binomial random variable, okay. So we always define it as the number of successes, so dependent on what the question is talking about, out of the total number of trials or your total sample size, okay. And this is the notation where you will define the binomial distribution. So you must have the two parameters, which is n as well as p. Okay, so we will look at one more example, and then after that we're going to learn something new, which is the mean, the variance, as well as the standard deviation. Okay, so we'll talk more about that later. Now let us look at the work example here, work example 8. Okay, so a fixed number of cars, which is n, is being observed, and we are taking a look at the number of cars that are red. And the question tells us that this is being defined by the random variable r. Okay, so the first part, state in context. Therefore, you must always answer the question in context. Two assumptions needed for R to be well modeled by a binomial distribution. Okay, so what I've just mentioned, the two assumptions that we will be talking about here will be the fact that you have independent trials as well as the probability of success is constant. But please make sure that even if the question does not say, okay, you should still be putting these assumptions in context. Alright, so the first one will be the probability of success being constant. So in this case, the success is a car is red. So we will write it as the probability that any one car is red remains the same throughout the whole sample. Okay, the second one is the fact that every trial must be independent. So according to the context here, we will write it and that the color of every car must be independent of the color of any other cars. Okay, so these are our two assumptions. Now let's move on to part 2. The question now tells us that R follows a binomial distribution with sample size n and probability of success p. Okay, so for part 2, you are given the sample size, which is 20. You are given the probability of success, which is 0.15. So let us find the probability, which you have already learned previously, okay, in the previous lecture. Okay, so every time you must write down the distribution. Okay, so in this case, we will write it as R follows a binomial distribution. Your sample size is 20, probability of success is 0.15. Okay, now I want to find the probability here, right? So if you recall, when you are using the GC function, there are only two functions, one being the binom PDF and the other is the binom CDF. Okay, so PDF is when you have equal, CDF is for less than or equal. So both doesn't work for this inequality that you have here. So what we need to do is to change it. Okay, if you're not sure, you can actually draw the number line. So what you need is from 4, including 4, 5, 6, 7, 8. Okay, so you want from 4 to 8, so it'll be 4, 5, 6, 7. However, it does not include 8, so therefore I will not include the value when r equals to 8. Okay, so let me break this up so that we can use the GC. So we'll write it as the probability r is less than or equals to 7, and then you take away those that you do not want, which is r less than or equals to 3. Okay, so once you have this, then you see that we can actually use the binom CDF function. So use your GC, and then you will, give me a second. Use your GC, and then you will key in, your sample size will be 20. The probability of success here will be 0.15, and then the x value will be dependent on which value you are calculating. Okay, so if your value is 7, then you key this as 7. If the value is 3, then you key this as 3. Okay, then from the calculator you will get the respective probabilities, and then you can subtract and give your answer to 3SF. Okay, so that's part 2. Now part 3, you are given the sample size, which is still 20. Okay, and you are now given the condition for the probability of r equals to 0 or 1. Okay, so you are given this condition. You notice the question did not give you the probability of success. Okay, and you learned this in the previous example on how to actually use your GC to help you to find the probability of success. Okay, but take note, here the question says that you will need to first of all write down an equation for P. So this is actually telling me that I need to use the formula, which is the one, let me show you here, which is this formula, okay, that you can find in your MF26. Because that's the only one that will give you an expression in terms of P. Okay, so let's see how we're going to do that. So first of all, write down your distribution. Okay, then write down the condition that's given by the question. Now, how do I simplify this so that I can use my GC? So probability of r equals to 0 or 1 means the probability of r equals to 0 plus the probability of r equals to 1. Okay, so now you break it up, and then you realize that, okay, good, now I can actually use apply the formula. Okay, so I have the formula here again for you to refer to. Okay, so my n is 20. So whenever you see n, you replace with 20. My x value now, dependent on which one you are using, okay, will either be 0 or 1. Okay, so you plug in the values into the formula, then your equation will look like this. Now there's no need for you to simplify. You can't simplify any further. Okay, so once you have written the equation, and if you take a look at the question, it then says find this value numerically. Means after you have done the equation, written the equation, now you can use your GC to solve for the value of P. Okay, so let us see how we can do that. So what we're going to do now is to key in the left hand side into your y1. Okay, then followed by the right hand side, which is 0.2 into y2. So left hand side equals to right hand side means that you need to find the intersection of these two graphs. Okay, but you notice that on the left hand side, this value is actually a probability, correct? And then the value on the right hand side is also a value for probability, and we know that probability lies between 0 and 1. Okay, so you need to do some adjustment to the window settings. So if you look at the window settings here, my minimum x value is 0, maximum is 1. whereas for the y value, minimum is 0, maximum is 0.5. Okay, so this will help us to ensure that my intersection point can be actually clearly seen on the screen. Okay, so if you after that you press graph, this is the graph that you will see here. Okay, and to find the value of P, you just need to find the value of this intersection point, okay, which will be 0.142. Now, because you're using GC to find the value of P, right? So what you need to do is you need to label the graph. So you need to draw this graph as proof of your working, and then you need to label the graph clearly. So your horizontal axis will be, because you're solving for P, so your horizontal axis will be P, and then your vertical axis will be the y1 expression. Okay, so you draw this graph and then you write down the answer that you get from the graph, then this will complete your working. Okay, so this is example 8.